Hi, everyone. So, as I'm working my way back, I figured it would be a good idea to record a quick video with a worked example of a problem involving Boyle's Law. Now, Boyle's Law, as you'll remember from the gas laws intro, is a law that we follow when we have a gas that is at constant temperature. That is, we're putting it in a container, we are changing the pressure and the volume, but the amount of the gas as well as the temperature stays the same. So the equation that we use for that is, P1 times V1 is equal to P2 times V2. And as you're getting used to these problems, it's going to be really important to make sure you map out the problem first and figure out what you're working with before you just sort of blindly plug in numbers. Because if you put these numbers in the wrong place, that's going to make the problem much harder to solve. So let's set up the problem first. A gas occupies 1.56 liters at 1.00 atmospheres. What will be the volume of this gas if the pressure becomes 3.00 atmospheres? And we're adding those decimal points, even though it looks like we don't need to for the purpose of sig figs. So our answer will be rounded to 3 sig figs in the end. So what we've got to figure out is what these numbers are, and the units are going to tell us a little bit about that, and where to put them in our equation. So let's tackle this first sentence first. A gas occupies 1.56 liters. Now, if you've ever gotten a carton of milk or a bottle of soda or anything like that at the supermarket, then you know that one of the things that is used to measure volume, the amount of space something takes up, is liters. So this right here is a volume. And since it's the first volume we see, and we can assume that that's the initial volume, let's go ahead and call this V1. So V1 is equal to 1.56 liters. Then it says that it occupies 1.56 liters at 1.00 atmospheres. Now, an atmosphere is a measure of atmospheric pressure, the pressure of the atmosphere. And so that is our P1. And notice that I'm putting the units in here. When I crunch the numbers in the end, I'm probably not going to put the units in the equation, but it's good to get in the habit to make sure you have the correct units in your answer. So now we're going to read the rest of the question and figure out what we're actually solving for. So it says, what will be the volume of this gas? So that means that we don't know the volume yet. So I'm going to go ahead and put a question mark right here, and now we know that we're solving for V2. Then we're told that the pressure becomes 3.00 atmospheres. So that must mean that that would denote the only variable left. So that's 3.00 atmospheres. Okay, so now we've got all of our numbers, and so as my Algebra 2 teacher, Mr. Sperry, told me back in the day, now all that's left to do is plug and chug. If we have an equation, and if we know all but one variable, all that's left to do is plug in what we know and solve for what we don't. So I'm going to go ahead and do that, and I'm going to do that right up here on the top. Again, I'm just putting in the numbers here just for the sake of space. As long as you put your units in your answer, I'm okay if you use this method too. If you think you're going to forget, then putting the units in is always a good bet. So we have 1.00 atmospheres for our P1. Then our V1 is 1.56 liters. And then on the other side, we have 3.00 atmospheres. And then our volume is what we're solving for, and that's V2. Now, the units of volume can be different. We can use either milliliters or liters, or you may even see cubic centimeters as a unit of volume. Cubic centimeters and milliliters are exactly the same thing. So as long as you have the same units on both sides, the units of volume, at least for now, don't really matter. There will be a point at which they do, but not yet. So now we're going to solve, and the way we're going to do this is we're going to make sure we get V2 by itself. So the first thing we'll do is we'll multiply everything that is on the left-hand side of the equation, and I'm going to go ahead and put that down here. So 1.00 times 1.56 is going to be 1.56, and that is going to be equal to 3 times V2. So all that's left to do is to divide both sides by 3. And V2 is going to be equal to, I will admit, actually, I can do this in my head. I will admit that I should have calculated this beforehand. Doesn't make for very good viewing. But V2 is going to be equal to 1.56 divided by 3, or 0.52 liters. And so the way we're going to check our answer is we're going to figure out what Boyle's law tells us. Basically, what Boyle's law tells us is that the product of pressure and volume is a constant. And another way to put that is that as the pressure increases, the volume will decrease. And so we see here that we start with a pressure of 1, we end up with a pressure of 3. So the pressure triples. We would expect the gas to occupy much less volume, a third of the volume that it did before. And so as the pressure increases, we would expect the volume to decrease, and that's exactly what we see here. And so the math checks out. It makes intuitive sense based on what we know about gases, and that is how you solve a problem involving Boyle's law. Hope it helps. Have a great day.